Mass moles and molarity. When we look at this term mole, uh, we're not talking about the little animal, obviously. We're talking about MOL. So if you ever see MOL, it's really the amount of a substance that contains the same number of particles or atoms. So in reality, I'm going to go ahead and put a blue, because whenever you see mole, you're talking about an amount. We use Avogadro's number when we don't know the amount of the mole that is being used, or if we want to do a further equation, 6.022 times 10 to the 23rd. But more importantly, if we want to do something simple like this, how much ammonia will be produced from 5 moles of H2? Now, look here. This is the ammonia they're talking about. Okay, different diatomic sides of ammonia, or nitrogen hydroxide, as they would call it. But anyway, this is what you're doing. So you want to look at this 5, and you want to look at this H2. And you don't want to do anything yet, because if you were in algebra class, you'd go 3 times 2 is 6. But we're not there. We're talking chemistry class, so you do something else. Okay, so for instance, and here, this is the same thing as this before, so you don't have to pay attention to this. So you establish what is needed or what is being produced. 5 moles of H2 is going to give you 2 moles of NH3 over 3 moles of H2. Now, have you noticed something in common? This hydrogen, or hydride, and this hydride, or H2, they cancel out. And so it's established what is needed or what's being produced, and you had 5 moles over here because that's what needs to be produced. Then you saw that this was common, H2 and H2, and like step 2 tells you, you cancel both. You cancel them out. Okay, now when you cancel this out, you come over here and you have 5 moles. You have 3 moles because H2 is gone, and you have 2 moles of NH3. Well, we're still dealing with the algebra. When we deal with the algebra, we have 5 moles times, and these brackets mean to multiply, right? Times 2 of NH3, and you keep this NH3 in your equation. So your NH3 is going to come over here, and that becomes NH3. That's 10 NH3. And then this 3 moles is by itself. So guess what? You can pretty much kind of cancel this out over here. And you could even cancel it out over here, because it's known that it's moles that are needed. But you would do 10 moles. 3 moles. Because you're talking about moles over here and over moles, they become 1, and then you just worry about the algebra, the simple math. So that's 10 over 3, that is 3.3 moles of ammonia. That's what's needed. And again, moles is how much will be produced if 5 moles get in, and your answer is going to be right here, 3.3. So if you're on a test, it's 3.3, and you don't have to be so technical to talk about, what that means or what's going to happen. It's 3 1/3. Okay? And these are very good for titrations and for combination and even sometimes decomposition equations. 3 calciums plus 2 nitrogens yields 3 calciums, 2 natriums. So calcium nitride. Some people say because 2 calcium nitrate. Okay, it doesn't matter. Calcium nitrate, right now, you just need to get a hold of it. So now they're asking how much calcium is required to produce the 3 atoms of calcium combined with N2. So this is actually a combination equation, but they're asking you do you need 5.4 moles? How much calcium exactly? What is the calcium in this whole compound? And so that's where your molarity or the number of moles comes in. Now you have to be careful. Um, it is 1 mole of Ca3N2 and 3 moles of Ca is going to give you a product. So you need to set the equation. You don't have to combine like terms you don't have one. Your bottom number over here is a 1. So that means that the bottom of your equation is a 1. So you now don't really have to reduce anything because it's already been taken care of for you. So you just straight multiply 5.4 times 3. And when you do that, you're going to get 5.4. Some of you are going to be faster because you already have a calculator. But let's look at what this does. We can leave this. This is a placeholder. This is 0, 0. This is 0 here. This is 3 times 4 is 12. And this is carry my 1 is 16. And I'm really sorry for my bad handwriting, but you have 1, 2 spaces, so it's 16.2. And this here was supposed to be a 0 that was holding. But this way we know for sure that we are actually doing the equations. This is upside down, but this is 16.2. So this equation may look hard, but your mind has to do things. Think about the chemicals and also think about what it's asking you. It's asking you how much to produce an entire compound. And it gave you 5.4, so you put that here at the beginning, over here to produce 3 moles. So you always put what up top is what you need over your divisor over here, 1 mole Ca3N2, and then you get your answer. Okay, you have a divisor here, but when you multiply, this gets rid of the 1 mole because 1 is 1, and so this is really 16.2 over 1, which is 16.2. If you have any questions, we're at jacobitslearning@gmail.com. Thank you.